everyone. So this is the second part of fourth unit, that is wind energy. And as everyone is familiar with this type of energy, wind energy, and it is also termed as sister of solar energy, because the wind energy is the only this is the type of energy which is nothing else. It's the kinetic energy of air and wind, which can be gained by the temperature difference at the various parts of Earth's surface, as well as ocean surface, as well as the tropical and pole zone of the Earth's surface. So due to the temperature difference, so density difference is there. A density difference is the only cause behind their flow, and that is also termed as kinetic energy. So there are basically mainly so many devices that can be, by with the help of them, you can utilize to convert these kinetic energy of wind or air into the electrical form of energy, and that's very so simple. So that is also the very term the windmill, in very from the right from school time, right from beginning of our childhood, we are hearing about the terms windmill, or we can say wind turbine. So how they work, the phenomena behind this is only the thing that we have to know about it. So first of all, I would like some brief introduction about the wind energy and what are the types and sources here. Then we will go for then go to mechanism, how it's work, and ultimately the link, the, that is termed as wind mill or wind turbine, and type of wind turbine, and mode of operation, and the effectiveness, and the parameters which are going to be govern our efficiency and output of conversion of this device. So first of all, wind energy and its source. So as you know here, as you are observing here, there are local winds and planetary winds. So local wind, what about this local wind? So what is the local wind? Local wind is termed as sea breeze, we can say sea breeze or surface breeze. Surface breeze, not a breeze, it's a breeze. Means it's very cool air when the flowing, that is called breeze. The local breeze and the surface breeze. So but what the local breeze or surface is here there. So what happened, uh, as the at the land place of the earth surface, it is bit hotter than the surface which is near about the coastal zone. It is somewhat cold as compared to the surface near about the Rajasthan and all. So just because of this, so temperature difference, obviously the air is nearer to the coastal zone, it's somewhat cold in temperature, and the air which is nearby this hot zone, hot surface of air, earth, that is somewhat hotter. So due to this, the density difference is great. A density difference is the only cause for flow of wind, that is called the blowing wind is blowing. So why wind is blowing? Due to the density difference. Okay, as well as the due to this density difference, and so daytime what happen is the land place is hotter than the coastal regions. So the breeze are flowing from coastal region to land surface of the earth, and in night times it just vice versa. So that is the hot airs is flow from that place to earth surface. So because of this flow current of this air, so when we put some obstacle in the across this flow, so what will happen, due to this due to this flow due to this flow, this is able to make produce and thrust. That thrust is able to turn a blade or any mechanical means in a very prescribed manner. So if we make a device in such a way that this potential of this air, then kinetic energy of this air is going to convert in a one kind of thrust or any type of couple or movement that can rotate any rotor, and then rotating device when it's coupled with any dynamo or generator. So finally this mechanical energy, first of all the kinetic energy of that air is converted into the mechanical energy, that is in a rotatory, due to this rotary motion of shaft of wind turbine, And then finally, this mechanical energy, when coupled with any dynamo or generator, then being converted into electrical energy. This is only our purpose to get the energy from wind kinetic wind to electrical. So next topic is the planetary wind. What comes the planetary or the idea about the planetary? So as we talk about the planets, when we say something about when we say talk when we talk about the Earth, so what happened there is equators. On equators, as you know, it is hotter than the terminal zones of Earth. That is becomes the North Pole and the South Pole. And in the northern hemisphere or southern hemisphere, obviously there are some cold surfaces, and as compared to equators we can say that the tropical zones. So because of this the nature of zones, because tropical zones and has northern poles and southern poles, they are cold in temperature. Due to this temperature difference against the density difference occurs, and the air of flow is flowing across the planet, not between the land to water surface, land to ocean surface, or sea surface or sea coastal region. The flow of wind is occurring something across all on over the surface of the earth surface, over the surface of earth only. Okay, so that's why it is termed as planetary wind, and the function and working and mode of operantis of this type of wind is also the same. So yeah, so next is the mechanism, how its mechanism works. So as you can see here, this is somewhat about the mechanism part. So I would explain you. First of all, they see what happened. This is the rotor of wind turbine. This is this we can say, and this is the area of cross section of inlet. This is the area of cross section outlet, and the velocity of wind at this point is V in. Velocity of wind here is V out, and the area of cross section A in or area of cross section in our exit point is A out. So ultimately that is the P in P out is the power, is the power obtained at this point, and is power obtained this point, you can say. Okay, so we will here I will discuss in detail with the help of some expression. So just if suppose m is the mass of air moving with the velocity v per unit time, then the power associated in general terms, in a very school classes we can say the kinetic energy can be written as 1/2 of the mv square, where m is the mass and v is the velocity, and half of this is the mv square is the kinetic energy of this one. Okay, if suppose a is the area of cross sectional of the wind stream, rho is the density of air, because only thing the density is it a dependent parameter which depend on the temperature. So higher is the temperature and lower the density, and lower the temperature higher the density. These are the difference of air. So yeah, so keep it remember and keep it in mind always the different relations between density and temperature, because we can just change the temperature. Temperature is going to be changed with the help of solar system, solar energy. It's okay. So ultimately the temperature is directly governing the density of the air, and ultimately the density governing the energy, the kinetic energy, flow energy, we can say velocity energy, the velocity of the wind. So mass flow rate can be written as m equal to rho a v, where rho is the density, a is the area of cross section, v is the velocity. So mass flow rate here we can say when a multiplies with v, that means this becomes volume. This becomes volume, and rho is the density. Density can be written as it is a mass per unit volume. When we cancel volume with volume, so ultimately it becomes mass. And here the velocity per unit time. That means mass is flowing per unit time. It is termed as mass flow rate. So rho AB is known as, it can call it is termed as rho AB is a mass flow rate. So when we put value of m in this formula in equation 1, so this formula is going to be turned in this type of frame. So 1/2 of rho a vq. Okay, this equation number 2. If the diameter of wind aero turbine, if the diameter of wind aero turbine, that is capital D, so ultimately area of inlet is pi by 4 d square. It is the diameter of that rotor, turbine rotor. So a, that a can a in place of a we can what